Okay, there we go. Hello, everyone, and welcome to another virtual meetup. We have a really exciting presentation for today, but first, the usual few messages from your Elastic DevRel team. Real quick from our side, quick introductions. My name is Olivia. I am a program manager. I'm also joined by Justin.
Hello, everybody. Justin Castilla here, Senior Developer Advocate at Elastic.
Perfect. I'll cover one slide on how to get involved, some resources we have here on our DevRel team, and then we'll turn it over to Dr. Wes Peck, who will be presenting, followed by Q&A. So throughout the presentation, if you have any questions, please post those in chat. At the end, we will have plenty of time for Q&A to get any of your burning questions answered. Real quick, if you have any questions, Elastic related questions, or want to learn more, we have a few great resources that I will include in the chat here shortly. We have Discuss, which is our forum for you to get any questions answered. You can also answer questions from the Elastic community as well. Join our Elastic Community Workspace, another great resource for announcements, questions, all of that. And then, of course, our community YouTube channel, which is where this video will live. We do a lot of virtual meetups. We have a lot of different content on various use cases, solutions, so definitely check that out. And then, of course, if you are interested in presenting at an upcoming meetup, so whether that's in person or virtual like this one, we want to hear from you. Doesn't matter if you're a beginner, intermediate, advanced, we welcome content of all different genres. So definitely reach out if you would like to present. And then, of course, our user group chapters. So we have almost 150 user groups globally. Definitely would love if you take a look at our chapters, see if there's one in your neighborhood, join, stay up to date with what's going on, and attend an in-person event. And with that, I will turn it over to Dr. Wesley Peck. And there he is. Perfect. You're good to go.
Awesome. Thank you, Olivia. I appreciate the opportunity to speak with you guys today. So the talk I'm going to give here today is about enhancing decision-making and incident response in a high-performance cluster using Runtime Integrity Appraisals and Elasticsearch. So we'll kind of get into what those words mean and that sort of thing here in a second. So like Olivia said, my name is Dr. Wesley Peck. I got my PhD from the University of Kansas in 2012 in the Computer Systems Design Laboratory. And I'm now the Chief Technology Officer at Invary. It's a startup based in the Lawrence, Kansas area where the University of Kansas is that uses NSA licensed technology to do runtime integrity measurement and verification. And we're applying that to all kinds of different systems. And in this case, you'll see a high performance cluster for a customer that we're working with. My background, my dissertation is in hardware software co-design of a verified trusted platform module via specification refinement. That is a very long title because that's what they require when you do a dissertation. I did a lot of hardware software co-design of operating systems as part of my PhD research as well. So very familiar with how operating systems are designed and implemented in both hardware and software. And then as far as Elastic goes, I have quite an extensive history of using Elastic in hyperscale IoT systems and spatial data systems for powering search and that sort of thing. So the use case setup here, we're working with a customer. They have a multi-tenant high-performance cluster that is utilized for AI training, large-scale simulations, all the things that you would use a high-performance cluster for. These clusters range in size from, 1,000 nodes to 10,000 nodes. So they're relatively large clusters, relatively high-powered clusters. And they're very interested in ensuring their clusters maintain their performance regardless of the security solutions they have in place. So their kind of environment, they have no trust between any of the parties in their environment. So they're hosting workloads that they don't necessarily know what's in the workload. And the tenants running the workloads don't necessarily trust the operators of those workloads. And so they kind of need to establish trust in this environment before anybody wants to do the things they want to do. So this environment's orchestrated by a Kubernetes cluster. It's monitored by Elastic, and it's measured by Invary. They have in their production environment some other security tools they use as well, but we won't talk about those here. So we're going to show how we can appraise the runtime integrity of the cluster. In between jobs is how they run this in their production cluster. So they'll run a tennis job, and after that job is done, they'll do an integrity verification in that cluster, make sure that data confidentiality and cluster security is maintained before and after that job. And the example we're going to see here is just running periodically. It makes it a little bit easier for a demo, but we support kind of both of those things. And then the appraisals are streamed into Elastic, and they're integrated into the SIM and the DR and the NNE analytics, so that we can have trustworthy observability and actionable IR. And so this we'll get into in a second, but there's really a kind of synergy between Elastic and integrity measurement where both of them get better with this in place. Next slide. So, but first I want to give you a bit of background on integrity and what integrity measurement is, and specifically what runtime integrity measurement is, and kind of how I view integrity measurement and monitoring and observability and how they're different, but also how they work together. So what is integrity? If you look at the Cambridge Dictionary, it's very generic, the quality of being honest. And when you apply that to a computing system, it's normally taken to mean the quality of being trustworthy. And that word trustworthy there is very broad, both in terms of who or what is trustworthy, but also in terms of the context of that trust, right? So I'm not going to trust a user to do anything on any system, right? I might trust this user to do to use these applications on this particular computer. So we try to be broad there, but context is important when it comes to computing. So integrity measurement and verification is a systematic method for removing assumptions in system design. So very important for zero trust architectures. I can take anything that I'm currently trusting, and if I can define a way to measure that thing, then I can define a way to do integrity measurement and verification over that thing. And by doing that, I'm no longer assuming that thing is secure. I'm verifying that it's secure. So that's a lot of words, but I'm sure everybody on here knows kind of what integrity is. If you've worked with computers before, it's a very common thing, right? So if you're in an at-rest environment, file integrity monitoring, Linux IMA and EVM, whole disk encryption, the trusted boot process, all of these things are concerned with verifying the integrity of data at rest. In transit, we have SSL and TLS and VPNs and IPsec that use encryption technologies that have integrity inside of them in the form of signatures or hashes. And then kind of more recently, we're seeing a lot of use cases for in-use privacy and security and integrity. So stuff like homomorphic encryption, trusted execution environments are a little bit older, but Intel SGX and ARM Trust Zone kind of fall in that category. And more recently, we're seeing a lot of activity in the kind of confidential computing area. So AMD's come out with their 7S&P stuff. Intel has their TDX stuff. ARM is working on their CCA, their confidential computing architecture. And then, of course, Invary was founded around this runtime integrity idea. So kind of what is the difference between integrity measurement and verification and monitoring and observing? They're interrelated and they worked well together, but measurement and verification is really establishing trustworthiness of something by measuring the state of that thing and then verifying that current state against some sort of expectation. So an example there is in file integrity monitoring. I'm going to just do a SHA-256 hash of a file, and I'm going to verify that that is the same as a hash I've taken in the past, right? That's a very simple example, but I know if the hash hadn't changed, the file hasn't changed. Monitoring and observing is really establishing trustworthiness by collecting events and analyzing those events to produce observations, right? So I'm going to give an example of that in a second, but in an at-rest world, monitoring observability is not really a technique that can be used in a system that's fully at rest. So you can have partially at-rest systems, of course, where the system's running, but there's a bunch of files at rest. So there's some monitoring, observing you can do in that kind of environment, but a fully at-rest environment, not so much. So in use, kind of extending from that use case, really same definition here, measure and verify, except now I'm working with in-memory state and have both data and computation, right? So I want to look at all of the data that is in memory. I want to look all of the code sequences that are in memory, and I want to verify those things against a set of expectations. So in Invary's world, we have a version of integrity measurement that works over operating system kernels, and it does that by going in and measures all the data structures that are quote unquote interesting inside of a Linux kernel or a Windows kernel. It pulls all of the code sequences in that kernel, and then it matches those against a set of expectations. And then in this case, the expectations are not simple hashes, right? So we have this concept of a golden image or a baseline or a previous measurement, or however you want to think of it, that's taken in a well-known secure area. We can use that well-known secure measurement to then secure things that we don't know if they're trustworthy or not. In this case, by saying, have I seen this data structure that I saw in memory over on this target machine? Did I see that same data structure in a way that makes sense in my golden environment? And that sort of thing. We can get into the details of there if you want, but this presentation is not really about that. But monitoring, observing, same definitions of before, right? I'm collecting events and I'm analyzing those things in the Elastic world, in any kind of XDR, EDR system. Example of that is just, I want to make sure a laptop's trustworthy on my network, right? I'm going to go collect a bunch of packets. I'm going to analyze those packets, and I'm going to observe some things about those packets. In this case, I'm saying I could look at what all external services are being accessed by that laptop and make sure it matches my policy, right? So, and then just real quick, you can combine the lifetime of these things to build stuff that's got kind of what I call full lifetime integrity, right? So if I combine at use with in transit with in use across a timeline, I can make sure that I have verified integrity or verified trustworthiness from all the way through runtime. Right, so I can use stuff like secure boot and IMA and kernel lockdown mode up to boot, and then after boot, I can use some of these runtime integrity appraisal stuff, and I can use monitoring and observability stuff, and kind of gather a picture as to the trustworthiness of the system I'm trying to measure. So what this picture is showing is just the T0s through T3s and beyond. That is integrity measurement looking at state. And then there are events happening between those states, or that are kind of represented by the E0 through the E3 and beyond. And that kind of gets into a little bit of an initial picture as to why these things work together. But that's kind of what I'm trying to show here. And I'm going to spend very little time on this slide because I'm told it's too mathy for some people. But I really view state and events as duals one another. So you can take perfect state, and if you have perfect state, you can difference those perfect states to produce an event stream, and vice versa. If I have a perfect event stream, I can aggregate them up into a perfect state. And perfect here really means I can measure everything about every single state, or I can capture all of the details about every single event. That is obviously not anything that we can do in the real world, but there's some analogies here to derivatives and integrals in math, and duality of streams and tables if you're a data scientist. And why is this important? It kind of means that integrity measurement and monitoring observabilities are two sides of the same coin. And if they're two sides of the same coin, they're two sides of looking at trustworthiness or integrity in a system. That means that if I trust a particular state, that says something about trust of events that happened before that state. And if I trust a set of events, then that means something about trust in the state that was produced by those events, right? And so something is very not clear in an imperfect world, right? In a perfect world, I can say it's perfectly trustworthy, right? But we're not in a perfect world, and so you kind of have to make a trust decision in these cases. And so we're nowhere near perfect. And so instead of saying we're just going to trust it, we're going to say I have to make a trust decision. But now I know that integrity measurement and monitoring and observing can kind of influence how that trust decision is made based on what decision is coming in. Sorry, data is coming in. So demo here. Hopefully this goes well live, but I have some backup slides if not. So this demo here is really combining these two parts to make something more powerful than their individual pieces. And this is because we don't live in a perfect world. Because we don't live in a perfect world, I want to take monitoring and observability over events. And I want to take integrity measurement over state. And I want to combine the good pieces of both of those together to come up with something that's even better than the individual parts. The analogy I use here is GPS and inertial navigation systems, right? You can do navigation with just GPS. You can do navigation with just inertial navigation systems. But if you combine the two together, I get a system where I can have very high speed navigation data coming from our inertial navigation system, a much higher speed than GPS can allow. And then I can correct that inertial navigation with very accurate and drift-free GPS measurements to make sure it kind of stays on target. So I feel, I guess from my viewpoint, we can kind of do the same thing with trustworthiness in our systems. I can use the monitoring and observability that Elasticsearch is giving me, and that gives me very high speed insight into what's happening throughout my high performance cluster or whatever you're applying this to. But then I can make sure I'm not drifting in my trustworthiness by taking snapshots of integrity at certain parts over state and kind of quote unquote correcting my trust decision over time. And that's kind of what we're trying to show a little bit here. This is a very simple demo. We couldn't show the production environment. So this is a very micro environment we've been setting up for the last few days, but hopefully we'll get the point across. So Elastic obviously powers up Invary's runtime integrity ports a lot. Elastic is a highly sophisticated product. It has all kinds of data aggregations and data visibility and time series reporting and that sort of thing, and alerting and SIM rules and case management and incident response, all of that kind of stuff that we don't, as a startup, want to build into our product directly because we just don't have the time, and that's not our focus as a company. So by putting our apprentice, we kind of get to use a lot of that stuff, right? We get to use their latest transform to track the level status of any given endpoint. So I can just send you appraisals as they happen, and you can aggregate them up into a last known set of endpoints for me. I can use your data discovery and visualizations tools to slice and dice my integrity measurement and verification results, and go and see all kinds of interesting stuff that's happened. We can use your machine learning and anomaly detection, your log rate analysis stuff to really make sure that not only the system's behaving correctly, but I'm getting those appraisals in at the points I'm expecting to get them in, right? If we want to use them as a way to combine with this monitoring data, I want to make sure they're happening regularly, and using Elastic's tools, we can do that. And then, of course, rules and alerting, we can take action based on integrity reports, right? So if an integrity failure, especially of something like an operating system kernel happens, that is a very strong indicator of a very severe issue. And so in this case, Invary's integrity reports are being used to power up some Elastic's features as well. So we're going to pass this strong indicator into your SIM detection rules, your detect and response stuff, and your entity analytics stuff. And we're going to see that it can make very strong decisions and lead to very strong incident response. So I know something very important has happened. So this is just a high-level architecture. It's a very simple demo here, like I said, but it does replicate the kind of high-level aspects as what's happening in these high-performance clusters. So I have Elastic Endpoint, I have Elastic Agent on a set of nodes, in this case just 3. We have the Invary sensor running on all of those nodes as well. And then the Invary appraiser running on one isolated node in the cluster where all the sensors are reporting their measurements over that thing. And it's doing the verification part, the part where it's trying to match the measurement against the expectations that are in place. And so then everything just flows up to Elastic Cloud, and we can see all of the things from there. So let me see if I can't, this is for afterwards, but let me see if I can't show my screen. I'm going to share my screen, the whole screen. Are you guys seeing that now? Yes, you are, because you're getting the mirror effect. So can you now see this security project? I'm not getting any feedback, so all right, I'm seeing a thumbs up. So I'm going to just show a few other things here, and then we can get on to the Q&A session as well. So, all right. Like I said, we haven't customized this very much. The production cluster is much more customized and has a lot more dashboards, but we're just really looking at the appraisals and what they are. And so I already have a set of appraisals coming up in here. None of them are failing. We'll try to cause a failure here in a second, but I can already click on this and already see a bunch of interesting stuff about these integrity decisions. There's random IDs in here and stuff like that for tracking measurements. But I can see all the agent versions of all the Invary sensors running in here. I can see all of the different integrity checks we've made. In this case, this is the Invary operating system kernel integrity check that's happening. And that integrity check actually does integrity over a variety of different things. And so we do report on each individual thing. And then we can see an overall status somewhere in here. I think it's on page 2. It's rolled up into an overall status. This is what actually gets used to feed into Elastic's kind of SIM tools and discovery and response and that sort of thing. We could feed some of the more detailed information as well in. I'll talk about that in a little bit of a second, but it kind of be an interesting thing for us to do for sure. And then there's some stuff that overlaps with, the stuff that Elastic collects on its own. So node names and uptime and stuff like that. And one of the things I wanted to point out was there's a pretty interesting section in here. Let me see if I can't make my screen a little bit bigger so we can see that real quick. On Invary is doing a measurement over the system, and it has a bunch of stuff in here saying, hey, I found some stuff that's not necessarily an integrity violation, but I wanted to make you aware of it. And so it found some stuff around some F traces being active inside the kernel. And in this case, the reason I'm showing it to you is because these F traces come from Elastic's Defend product. And so Elastic is using this F trace functionality within the kernel to gather events in your system. And it's reporting those events up to up to the Elastic Cloud instance for analysis and observability purposes, right? And we're going to have rules that go over all that stuff that Elastic's defending. But those rules depend on the kernel having integrity. Elastic's using the kernel to gather this information. So if the kernel doesn't have integrity, then the information that Elastic is gathering is incorrect. And the data that's going are potentially incorrect, I guess I should say. And that potentially incorrect data is going to flow into your SIM. And if you have, for instance, a rootkit piece of malware sitting there hiding events from you, you might not see the things that you need to see in Elastic to have the kind of detection and response and incident management that you might want to have in your cluster. So this is kind of an area where it's together, they're working better, right? So I have all the stuff I want from Elastic, and Invary can come in and make sure that the stuff that Elastic's depending on is working correctly on each and every machine in your cluster. So zooming back out. Let's go ahead and try to compromise. Oops, for my backgrounds. One of the nodes, and hopefully my connection is still live. So on this machine, I have a rootkit that we co-developed with the NSA. It is a benign rootkit, meaning it just prints out that it's doing stuff. It's for learning purposes and for demo purposes. And I'm going to load that rootkit into my machine. In this case, I'm not trying to demonstrate an actual method for hacking a computer. That would be that would violate, I guess, my integrity and honesty. But we're just going to load it in with insmod because I'm not trying to be an actual hacker here, and I have to do that as root. But all of the things that this rootkit does are based on things that happen and have happened in the real world. The rootkit's based on Drover Rub, real world Russian rootkit. It emulates its behavior, but it doesn't actually do any sort of exfiltration or credential capturing or anything like that. It just prints out stuff a lot to the kernel logs that says, I'm doing this stuff. I'm not even going to show you how it works, but point being is we should, in a minute here, get in a failed appraisal. And while we're waiting for that, I want to go look at the kind of rules that we have set up for this. And we have this rule that we set up. This is one area where it'd be kind of interesting for us to break down our overall high-level status and use individual statuses, especially for this MITRE attack stuff here, right here. So the analysis we're doing does do a lot of integrity measurement over the kernel, and it actually knows in quite a lot of detail where in the kernel the integrity has been violated. And so here I have this just saying if I have detected a kernel violation, it can do all kinds of stuff. It can extract data. It can act as a man in the middle and collect stuff. It can have a keyboard sniffer in there and collect credentials. It can compromise host binaries and do all kinds of stuff, right? So I just have all of them listed here. But if we broke down our analysis enough and fed enough information into Elastic, I believe we could actually target each individual one of these, right? I could say, for instance, I saw a compromise in the network stack of your Linux kernel that is likely going to lead to some sort of automated exfiltration. And I can kind of break that down on a lower level and say what parts of your kernel have been attacked and how that maps to your MITRE attack framework. And then that can feed into the rest of Elastic's product, as you know, and you can take action on that. So that's kind of the way we're moving. Right now, we just have this high level. If the kernel lacks integrity, that's a critical event, very high risk score. Here's all the stuff that could happen. And these are just our matching rules and that sort of thing. And here's where I'm saying, really, I'm only looking at that overall high level status right now. So hopefully, going back to my board, we have an appraisal failure in the last minute or two. All right, and so you see here, we have now passed an integrity failure in here from that particular machine. One of the things that I did do for the demo was, of course, you can, in your rules, going back there, I can take actions based on these. We had our actions isolating our node at first. I turned that off for today's demo. But this is how the production cluster works. We would know this isolate rule in here. I can try this in a second. Sometimes it messes with the demo because the node goes away and then I don't see my data anymore. So I'm leaving that off for now. But we can try that in a second here and see what happens. So we got that a failed appraisal in. And so we should see a new alert, and you can see there's a new alert here. You can see I've been testing this all day to make sure it works for this demo. But the point is I have this runtime integrity failure. I can see it on here. I can click on all of this stuff and observe it, right? So my high risk score that I had, all of the stuff it has, it telling me all about the MITRE ATT&CK framework stuff that's going to happen. This really makes it easy for the operators of this high performance cluster to know what's happening in their kernel and know, how they need to respond to it. Like, do I need to hop out of my meeting right now and go look at this, or is it something I can look at later? Elastic makes it very clear with all of this information what I kind of need to do that there. And let's see. You, of course, can add these to new cases and that sort of thing. So I'm sure you guys probably know a lot more about this stuff than I do. But they use this case management stuff, and they use the investigation stuff, and all of the things that Elastic kind of builds on top of this inside this production cluster. It doesn't demo as well here just because I don't have nearly as much data here. We mostly have the appraisals. We have some logs coming in, some metrics coming in from the platform as well, but nothing really interesting is happening in this cluster because it's pretty much running idle, just waiting for me to cause an issue here. But you can go in here and do all this stuff, and it shows you, of course, interesting things happening in the cluster. So it's showing you, in this case, it determined that run C was terminated. Sometimes this looks a lot more interesting. Sometimes it actually shows the Invary sensor doing stuff and that sort of thing as well, saying that the Invary sensor was doing things around when the rogue attack occurred, but not showing it this time. So then they also tend to use these detection and response and entity analytics dashboards a lot when they're looking at stuff. And in particular, the detection and response stuff makes it very clear what alerts are currently open, what rule name fired on them, what the criticality is, that sort of thing. And then also what hosts are being affected down here. Which this is very, very useful. And especially you can see that this was pretty much just by looking at this, that this was caused by root access on this box. I was able to do something as root and it caused some issues here. And then if I click on this machine, of course, I see that it's having issues and that sort of thing. This would, if I had my isolate rule turned on, this would have gone to isolated instead of healthy. And it shows all the events and that sort of thing. And then the other kind of main piece, I shouldn't say main piece, all of it's great. But one of the more interesting pieces, at least for integrity measurement integration, is, of course, this entity analytics dashboard where I can go look at, well, I kind of skipped over the first part of it, of course. So obviously some of those same users, I can still see that, excuse me, this root user has a very high risk score because of what I've done on this system. And interestingly as well, it can tell that I've come in as the EC2 user. That's how I initially access this AWS box. And it also detects that user is having some critical risk as well. And then, of course, down here, this is the main machine. This is a testing machine. You can ignore that. But this is the machine I compromised, and we can see very immediately that it's having issues, but it hasn't really spread to anywhere else in the cluster yet, right? So if there was any sort of lateral movement in the cluster, I'd be able to see all of the machines that have been affected here. So then I can click on this guy to see that he's had an extreme event here. All of the data I would ever want to know about this stuff. And of course, you can just plop this right into one of your investigations or one of your existing cases. But it's also very interesting to look at these risk contributions. In this case, you'll see that this node is having issues and it's kind of gathered up over time as I've been messing with the cluster, making sure the demo works. And it's got to the point where it's saying like, this is a huge issue here that you need to go look at. So that is it for the kind of demo part. So I think we're back to questions here, Olivia, if you want to, if you and is it John want to take that? Sorry, Justin.
Justin, you're muted.
So sorry. I made a couple good jokes, and basically most of that was thanking you for blowing our minds and giving us that deep dive. While everybody is typing up their questions, I just had a couple that I wrote down as you were presenting. I always I'm a bit of a rubbernecker when it comes to incidents. Do you have any real world scenarios where runtime integrity violation occurred? And if so, how did the response unfold for that?
That is a difficult question for me to answer. The answer is yes. We have absolutely detected stuff inside operating system kernels with this stuff. The reason it's hard to talk about is a lot of our deployment rates right now are within the DoD.
Gotcha.
Normally not even, we're told that they happen, but we're not told any details. I don't hold security clearance specifically so I can go on things like this and talk about it, but I don't know the details there. So
got it. So your service is excellent and working very well, but they just can't tell you any details.
Yes, that's the feedback we get a lot, unfortunately, is we were kind of in a trial recently where they're trying a lot of different security products together, and they were giving scores to each person, and they were commented back to us, "You scored very high," and that was all they would tell us.
That's awesome.
So we do see these in the real world. Our rootkit, happy to, if somebody wants to reach out, we can do a demo of exactly what's detected there. I didn't want to talk all about Invary in this, of course, but the rootkit does detect a lot of different things, and a lot of those things do flow into Elastic, and so you get a lot of information about not just where what integrity violation happened, but where it happened, right? So it's actually stuff like, in fact, I probably should have shown it in the demo. I forgot to click on one of the failed reports and show it, but it'll show you stuff like the system call table has been overwritten, or this data structure called ext4 file system open has been changed so that the function pointer here points to this function over here that I don't know anything about, and that sort of thing. So that all flows into Elasticsearch and allows them to make decisions and take instant responses that are very specific. So as you can imagine in the DoD, a lot of the and even there are non-DoD deployments as well, but especially within the DoD, the incident response can be very difficult to make. You have to know exactly what you're doing. Sometimes these are running very critical systems. I can't just always shut them down, right? This isolate rule is not normally applied in those kind of environments. They want to do something much more sophisticated. So they want to know exactly what's happening, and Elastic makes that very clear very quickly.
Wow. Okay. Well, I love your answer around the detail. No, it's very interesting. And it was really interesting how you kind of framed it, how Invary powers up Elastic and Elastic powers up Invary, and it's kind of like a symbiotic relationship. Were there any challenges that you faced when integrating runtime integrity verification with the existing Elastic observability and security platforms?
Yeah, that is a great question. I had a whole slide about it, but it got into a little bit too much detail for a slide, and it's a lot easier to talk about. But one of the challenges we had, or we have, I guess, is related to this notion of state and events being duals of one another, right? And so I have this system where I take an integrity measurement at time t1, and I can take integrity measurement at time t2, and a bunch of events happened in between them, right? And so in Elastic, it's really easy to enrich stuff as it's coming in. But what I really want to do is I want to say at time t2, I can be reasonably sure that all of the events that happened between T1 and T2 had integrity as well. So I'd really like to go back in time, say I'm measuring every 5 minutes. I want to go back 5 minutes and say all of the logs and all the metrics for the last 5 minutes, I want you to re-enrich them and say all of these things are highly trustworthy now, right? And so I kind of want to partition this world into things that have happened before my last integrity measurement that I can have a pretty good amount of trust on, things that have happened afterwards that I might have some level of trust on, but not as much, and that sort of thing. And while Elastic is very good at enriching while data is coming in, it's a little bit expensive sometimes to go back in time and rewrite records like that.
Yeah, that makes a lot of sense. And then with the increasing adoption of AI, large-scale simulations in HPC environments, how do you see runtime integrity evolving to meet future security needs as they scale?
Yeah, absolutely. I think our vision here is to have runtime integrity that goes all the way from the chip level all the way to network transaction level. So we started with runtime integrity of operating system kernels because it's kind of an unaddressed gap right now. And it was something that the people who funded the initial work, the NSA, were interested in working on. But the techniques are applicable anywhere. And so we already have an integration with AMD SevSMP. If you look at that technology, there is a attestation component of that does a measurement of what is in the chip. And then they verify that the encryption of your guest is working correctly, and then you can get a report over that. So we've already integrated that into our appraisals to kind of show that chip level stuff. And then we're also working on doing integrity over eBPF right now. So eBPF, for people who are not as familiar with the Linux environments, it is a virtual machine that runs inside your operating system kernel, and so you can essentially load what are programs into the operating system at runtime without using a kernel module. And this is being used everywhere right now. So Cilium, Elastic probably is using it as part of its Defend product. I haven't really looked, so I'm not 100% sure about that. But Datadog and Windows Defender and all of these companies are using eBPF because it makes it very easy for me to gather information about what the kernel's doing. But nobody's making sure those eBPF programs are behaving like they're supposed to behave. And that's kind of research that we're doing currently with the NSA now. How do we go and make sure that the eBPF programs that Elastic has loaded, because it wants to observe these things, are not just unchanged, but also gathering the data, and they're hooking the parts of the kernel that are supposed to be hooked so that the right data is flowing to the Elastic agent and then up to the Elastic cloud. Right? So how do I protect that entire path for eBPF? And then we eventually see this getting up all the way up to the network level. There's a strong correlation between integrity measurement and remote attestation. So what I really want to do is I don't really want to talk to a remote party unless I know that remote party has integrity. So we've kind of got identity worked out there with TLS certificates, but I have no idea what's running behind that certificate on that port, right? It could be completely compromised software for all I know. All I know is it says it's Amazon.com and it's at this particular IP address, and then I start sending that data, right? So we'd really like to say, not just, hey, who are you and where are you, but what's your software stack look like? And does it look like what it's supposed to look like?
Looks like I have to create a to-do list for my security team. Taking notes here. So we actually have a user, Demetrius Knight. He asks, could you provide some insight on how you maintain runtime integrity during a disaster recovery event?
So maintaining runtime integrity during an event, normally if you're having an event, right, the integrity has been violated. So if I went back and showed the demo right now, it's just constantly saying this machine is still failing integrity, right? So it's still, my operating system has been compromised, it's still been compromised, that sort of thing. So you don't really maintain integrity during some sort of event like this. But what it can do is it can tell you if your incident response was effective in addressing that event, right? So if you are unable to just remove and isolate and replace, but instead you have to do cleanup because maybe you have data on there that you don't have anywhere else because maybe your backup plan failed for whatever reason, or maybe the system is running something that cannot be shut down ever. It's maybe powering a life support machine of some sort. and I have to clean it up, it can tell you if that cleanup was effective, right? Did you actually remove all of the things that were in the kernel that were infecting it or not? And then as you apply runtime integrity to other layers, that applies everywhere, right? Is the chip okay? Is the kernel okay? Is the software stack okay? Is my network card okay? That's kind of an interesting one I haven't mentioned, but a lot of the smart NICs or the blanking on the name of them, but the programmable NICs that are out there these days are actually running Linux kernels. And so is that thing okay or not, right?
Wow. Yeah. Well, if there are no other questions, I'll leave the floor open for any more. But I want to thank you very much for this presentation. And for our community, how can they reach out with any future questions, or how can they learn more from you?
Yeah, for sure. You can reach me at wes@invary.com or support@invary.com. So if you have any questions, invary.com, and go to our contact page as well. Any of those works.
Cool. And do you have any meetups or talks or conferences that you'll be attending, or any booths that people can look forward to that they can kind of schedule?
Yeah, we are going to a couple here soon. So we normally attend the Confidential Computing Consortium. They have a conference that is not exactly the same time, but it kind of coincides with KubeCon. So it should be around that time frame. We have another webinar that's happening near the end of February, where we're going to discuss in a panel format runtime integrity with a bunch of experts. So Pete Lascoco, retired NSA, will be on there. We're trying to get a researcher from the current Trusted Mechanisms group in the NSA that we're working with there, and then some industry veterans as well, kind of to discuss, runtime integrity and where it's going and why it's important.
Wow.
And then there's a KU cybersecurity conference that happens in April as well. It's normally quite good. We're going to be attending that as well.
Cool. So you're going to have a nice spring schedule.
Yeah.
Awesome. Cool. Well, thank you everybody for attending this meetup. Thank you very much, Wes, for speaking, and just want to wish everybody a wonderful Wednesday. Take it easy.
Thank you, Justin.